All right, today we are diving into one of the most mind-bending topics you can possibly imagine, time travel. And look, this isn't just for science fiction anymore. In the world of modern physics, this is a subject of serious, rigorous study. So let's get right to it.
So, let's just cut to the chase, right? Is time travel actually possible? Can we really do it? Can we break the forward march of time?
And this is where things get really, really interesting, because the answer from physics isn't a simple yes or a simple no. It's both. You see, physics treats traveling to the future and traveling to the past as two completely separate problems, and one of them is totally possible, while the other one is a whole lot messier.
So let's start with the possible part, leaping forward. Let's take a look at how, according to the actual laws of our universe, you could buy yourself a one-way ticket to the future.
The secret sauce here is a concept from Einstein's theory of relativity called time dilation. It's built on this revolutionary idea that time isn't some constant, universal clock ticking away for everybody at the same speed. Nope, it's relative. The speed of your clock depends entirely on how fast you're moving and how much gravity you're experiencing.
So, how do you actually make your clock tick slower than everyone else's? Well, physics gives us two main recipes for this. First, you can go incredibly fast, like really close to the speed of light. Or second, you can hang out somewhere with immense gravity, like right on the edge of a black hole. Either one of those things will slow your personal experience of time way, way down.
And the effect isn't just some tiny fraction of a second. It can be incredibly powerful. Just take a look at this. Imagine an astronaut takes off on a journey for what, to them, feels like 5 years. But they're traveling at 99% the speed of light. When they get back to Earth, 50 years will have passed. I mean, think about that. Their friends, their family, everyone would be 45 years older. They haven't broken any laws of physics. They've just taken a giant leap into Earth's future.
Now for that other method, gravity, there's a fantastic example from pop culture that actually nails the science. I'm talking about the movie Interstellar, which used this exact concept as a huge plot point. Remember that water planet they visited? The reason time got so warped there was because it was orbiting incredibly close to a gargantuan black hole. The gravity was so intense that time for the astronauts on the surface slowed to an absolute crawl compared to their crewmate who was waiting for them up in orbit. For every single hour they spent down on that planet, 7 years passed for the rest of the universe. That right there is gravitational time dilation, and it's 100% real according to physics. Okay, so traveling to the future, it's on the table. It's physically possible. But what about going the other way? What about rewinding the clock and going into the past? That is where things get so much more complicated and controversial.
So, the main theoretical candidate for a machine that could take us to the past is something called a wormhole. Its formal name is an Einstein-Rosen bridge. You should think of it less like a spaceship and more like a shortcut, a tunnel punched through the very fabric of space-time itself.
But, and this is a huge but, wormholes come with a massive list of problems. The biggest one is just keeping the thing open. To stop this tunnel from instantly collapsing on itself, you'd need some kind of bizarre substance with anti-gravitational properties. Physicists call it exotic matter. The catch? We've never actually found anything like it. So while the math says wormholes could exist, reality hasn't exactly provided us with the building materials. They are still purely theoretical.
But hey, let's just imagine for a second that we solve all the engineering problems. We build a perfect, stable wormhole. We step through to the past, and then we immediately face an even bigger problem. Not a problem of physics, but a problem of pure, simple logic.
This is the classic grandfather paradox. It goes like this. You travel back in time and you stop your grandparents from ever meeting. Okay? Simple enough. But if they never meet, then your parent is never born. And if your parent is never born, well then, you are never born. So if you were never born, who went back in time to stop them in the first place? You see? It creates this impossible logical loop, a contradiction that just seems to scream that changing the past is forbidden.
Now, a paradox like that seems like a total deal breaker, right? A dead end? But physicists are a pretty clever bunch, and they've come up with a few potential, let's call them cosmic loopholes, ways the universe might just be able to handle a visitor from the future without completely breaking its own rules.
So you've basically got two main camps here. On one side is the self-consistency principle. This idea says the past is fixed, you can't change it. So if you went back in time to try and stop your grandparents from meeting, you'd fail. Maybe you'd slip on a banana peel at the crucial moment, or maybe you would accidentally be the one who introduces them. The point is, whatever you do was always a part of history. Then, on the other side, you've got the many worlds theory. This one is way wilder. It suggests that when you change the past, you don't rewrite your own timeline at all. Instead, you just cause a new, parallel universe to branch off. So in that new timeline you created, sure, you were never born. But you, the time traveler, are still there, now just a visitor in a whole different reality.
You know, all of this, time dilation, wormholes, paradoxes, it all rests on one giant assumption, that we actually know what time is. But what if our most fundamental experience of it is just wrong? Let's zoom out and ask the deepest question of all.
Some of the most advanced theories in physics, like quantum gravity, suggest that time as we feel it, this river flowing from past to present to future, isn't fundamental at all. It might just be an illusion, something that emerges from a deeper, timeless reality. So maybe the ultimate question isn't, can we travel in time? Maybe it's, what is the time that we're trying to travel through in the first place? And that is a question that continues to push the absolute limits of human understanding.